Yes, so you'll mostly know the IFRS mission, and that's it. And as I said, I get involved with the education side of things, and Andreas Hines not on here, mainly runs all the technical stuff, and we do a lot of interesting projects which you can find out about by either looking at the website or seeing some of our previous videos, or just reading about information in Principium, which I'll throw a slide up later on that gives more details on that. But what we're talking about today is some work we are doing with a company organization called the Limitless Space Institute. Now, I just grabbed this off their website just today, in fact, or last night, because I like the picture of the image of the spacecraft. But it just happens, I noticed, to be a support us button. So if you feel like pressing the button when you go on the website, you can support the Limitless Space Institute. But they're a newer organization, just been around a couple of years, and they've got the funds to pay for technical projects to be done, educational activities to be undertaken, and that's why they're getting us involved to help them with that. And it's really exciting. If you looked at the mission statement and the values, etc., of the Limitless Space Institute, and you looked at I4S, we've been going since 2012. If you looked at those, there's a real big overlap, which is great to see. It means there's more and more interest in some of these activities, and it's really nice to see some people like Dr. Harold Sonny White involved, who is quite a well-known name in the business. Through various activities with NASA, and is now working for Limitless Space Institute. But why is this important now? Well, we want to create a course with them. And I always talk about this particular aspect is because I think there's a sea change of things going on at the moment, which is really, really exciting. This is what I hoped would be happening 40 years ago. So we're going to develop this course now because we're pushing on open doors to try and inspire people to get involved with space, with STEM, with, in the long term, hopefully, the technologies or whatever is required to go to the very outer solar system with human exploration, or even, as I4S is always pushing for, to try and go into interstellar space. This is such an exciting time. So I've just thrown a few more of these slides there. You've got people like Elon Musk. Now, this date, I think, is going to miss now, maybe 2024, get their first Starship. Who knows when they're going to land on Mars? He sets very ambitious goals, but you certainly can't knock him for what he's achieved. Is just absolutely amazing. And part of what he does, along with other, Blue Origin and other companies, is really firing up the near future. The near future being the target audience we want for this new course. And I love this thought that he's planning. He talks about 1 million people on Mars by 2050. And as I joked just the other day, is that bear with me, someone's trying to get in. See if I can get to. When we run the course, I'm going to have someone running the Zoom, which will be very nice. I won't have to do that myself. Can you still see the screens? Can you still see the good? Because very helpfully, my screen has disappeared. Right, it's back again. So when I get to this point, and I always get really excited, and I should calm down. I always say, calm down. This is like watching the England soccer team or football team when they go to a new world tournament or a European tournament. You get really excited about what the potential might be. And as 40, 50 years ago, I've been let down every so often. So I've got to calm down a little bit when we think about what could be happening in the near future. But that's what we're trying to excite the youngsters today with. Bring them into STEM, bring them into space science, bring them into thinking about deep space exploration and more. And one more slide on just there's other companies like this. Is a lovely concept to think about. Let's think about mining in space, asteroid mining, and then using those resources in space. And I'll bring up a couple more things in a moment, which that naturally leads to, which I think is really, really good. So this is back at the summary screen. So I didn't write a script, but then I realized I wrote an interim report a few weeks ago for Sonny. So I thought I'd just flick through some of the things I went through on there. So what we're thinking about a few months ago, I got into discussions with Sonny and Limitless Space Institute, and they're talking about they wanted this course. And they knew that we had a background in doing some courses, and they wanted us to produce something. And we went off and eventually came up with agreement we'd move forward with a 1-week course. And you know, that wasn't their original plan. Their original plan was, how many different courses could you create for us? Could you create a 4 to 8 week course and really dig into some of this material? And I said, it's probably a bit too early for that. We can come back to that later. Or could you do another course for high school students, you know, maybe STEM high school students, or, you know, senior school students, or maybe even non-STEM students? And I said, that's probably a different course as well. So what do you really want to tackle? And he said, let's encourage people who are already going down that road. So we're again aligning with what they want to do. But let's try and look at around the educational level of first year university students, freshman students. Let's target that sort of audience, and then encourage them to keep it within space, and then go on to work on some of these great projects we're interested in. So that's the discussion we went through, and started designing the course. I'll mention the fact that Sonny obviously knew that we'd done various courses. Since 2016, I think we've done 5 out of 6 years, we've done an ISU, International Space University, elective module for the students. And that's a 2-week module, and where, generally speaking, we did approximately half a day teaching, half a day research work or study work with the students. And they've been very successful, and we've done general interstellar studies stuff, we've done chipsat stuff, we've done world ships themed modules, so we've got a bit of experience with the ISU. So that's one thing that is in the background. But really, some of that information developed from what we called our Starship Engineer Day courses, and they were 1 or 2 day courses. And this one of the early ones in about 2015 or 2016 at the British Interplanetary Society, where we do reverse engineering or Imagineering, as I call it, or even Starship Engineering days, where typically we would look at some of the theoretical background to some of the stuff, and usually have a bit of teaching in the morning, and in the afternoon sit down with the students and start designing or redesigning starships, or, you know, take a, you know, Daedalus design and then pick it apart and redesign something, or that sort of thing. And that worked really well. And we've got, you know, regular sort of people turning up. You can see myself on the left hand side. Not very exciting. There we go. I'm there, but it's Kelvin Long here, who's the co-founder of I4IS. There's a few other people. Terry's in the background, but I don't know. It's no one famous particularly, but I don't know if anyone knows Sky News. That's it's Tom Cheshire, who's on the technology correspondence for Sky News. I think he's based out in the Far East at the moment, but you see him on the telly in the UK quite regularly anyhow, for doing various technology. And he was there to find out more about what we do. So we had a bit of experience with that sort of half day, and we used the workshop exercises because that really, we felt, decompresses the day. You know, a full day's teaching is hard for the instructor and hard for the students. So that was generally the way we like to do our sort of thing. And that information developed into what we called a Starship Summer School, Starship Engineer Summer School. And we held one in 2018. We would have had one in 2020, but that actually fell by the wayside due to the pandemic. And probably a lot of the material that, not a lot, but, you know, quite a bit of some of the material that was in the summer school that we did then can be moved and used for the Limitless Space Institute course. Again, we did lectures, lessons in the morning, and workshops in the afternoon, and the team of that day came up with a new design for a mission, which they spent the week working on. It was and you know, did a presentation at the end of the week and stuff. So we've got a bit of experience with the short courses, so that helps from that point of view. And we've got other material we've done as well, not directly relevant because it was aimed at school kids. We do a lot of outreach, and we've taught school children either in schools, or on this account we've done a couple of summer schools at the Royal Institution in London, teaching 13 to 15-year-olds and 16 and 17-year-olds about how rockets work and what happens in space, how we might go interstellar, all the way up to how we might go interstellar. For example, one we call skateboards to starships, we just look at how the physics of just stepping off a skateboard can be related to starships, and some of that feeds into what we do in other lessons as well. So we've got a nice background in the subject, which Sonny must have known about, and the LSI people at LSI knew about, and I guess that's why they came to us to look at that sort of thing. So off we set. There's a number of people who've been helping me develop material, but first of all, we looked at what was available. You know, with interesting discussion we had was, how can we avoid what's in standard aerospace engineering courses, because we don't want to just repeat what that is. And we found ourselves with a real tricky balance. We've got to cover some of the stuff that's in a standard aerospace engineering course, but we want to make sure this course is tailored towards our material. So it's more to do with the far outer system, solar system, rather than just standard aerospace. So that was a challenge we had, but we went through analysis doing that, and we eventually came up with a long list of titles for subjects that we were able to give to Sonny and to LSI and say, this is what we could produce, a number of these to fit into a course if you're happy with that. And we had a bit of haggling to and fro about what those subjects might be, and you'll see them in a moment, what we agreed on. We came up with a 1-week course, and it basically fell down to 5 days split into 5 modules, basically a daily module, around an introductory module, which we're just, in my mind, that's bringing possibly a variety of levels of knowledge for the students up to a similar sort of level. So that may be repeating some things that some have heard, but it will try and bring them all up to a similar level so we can then move on for the following days. And I'll go through some details on that. And the second day we decided on was to cover propulsion and power in a day-long module, specifically because I don't know, there's lots of aspects that feed in to the technology required for us to go the far outer solar system with human exploration and even further. There's lots and lots of aspects. But at the bottom, you can almost imagine that if we don't solve the propulsion situation somehow, then we're not going to these places. So we're going to look in some depth of the propulsion options available to maybe get us to these places that we want to. Now that second day is primarily focused more on from the physics and science point of view, and that's why it features before the third day, which is systems, when we're going to look at an overview of systems other than just propulsion that's going to go into a spacecraft design or a design for a mission to do on the far outer solar system exploration or not. So we're going to look at the specific differences. You know, there'll be an overview of everything that's required, but we'll be looking at the specific things that are different or more required, or more technology or more extreme situations have to be solved, and how that affects the systems that go into our missions or spacecraft designs. And on the fourth day, we're going to try and bring that all together by looking at the design process that you go through and think about the concepts and designs module, as we call it. And in that, we want to go through a few principles of design and also use case studies effectively of how we went through, people go through these designings, and in doing so, highlight some key historical or previous work that's been done in that field. And the last day, the idea behind the last day is trying to bring the students into the vision of what's for the future, and you'll see what that's all about. But I eventually persuaded Sonny that this is an ideal opportunity, maybe with the last or the preceding to last presentation, that we get in a guest speaker, because I know he has access to some very high profile guest speakers. So he's promised me that on the last day, one of the speakers will be, you know, a good speaker, but it might be sort of an astronaut or something that's got an engineering background that can really take the future visioning idea forward and inspire these students that we've got on the course. And we ended up with, this is the schedule I'm working on at the moment. Let me just say the timings are Houston times, if you're wondering. You can see the daily themes there along the top in the darker blue, and you can see the titles as they stand of the lectures that we'll be, of lessons that we'll be doing. I have to say that I was pushed quite hard by Sonny and LSI that they were very keen on these 90-minute sessions to do a subject, and they wanted 90-minute sessions and 4 of them a day. And they wanted them to be more academic rather than less academic, and they weren't keen on our means of decompressing a course is to use those workshops ideas to break up the death by PowerPoint sort of thing. So we've had to look at alternative solutions to that, and the team are working on different ideas to make sure that it's a bit easier on the instructors and it's easier on the students, that they see these 90-minute sessions and not totally fazed by the fact they think they're getting 90 minutes worth of PowerPoint slides, which in general they aren't, but the lessons are brought together in these sessions. I'm happy to take questions at any time through my chat. If you get a burning issue, you want to jump in and ask. Normally I prefer questions at the end, but I feel in this sort of more of a discussion thing that I'd be quite happy to take questions as you think of them. If you see something you think, well, what's all that about? So feel free to jump in if you want to and ask me some questions. But this is the outline of the lessons as we got them. There you go. Someone put their hand up. Is that Bern? You want to go and fire away, yeah. Bern? You're an expert, a professional in this field. So what's your question?
So I was looking for some topics that I do not find here. So the first one is the space environment, interstellar space environment with all the harsh radiation and things like that. In propulsion, there seems not to be solar sails in it, which is clearly an option for interstellar travel. And I think also the power system is very important, because every propulsion system needs a quite unique power system to work, and also communications I have not found. So okay. Are they excluded, or are they under covered under those topics?
Some are covered and some aren't. Let me go. What was the first one? Was the interstellar space and the radiation issues. I'm going to cover that on day 1 under aspects of science when I look at exactly some of those issues. I've already forgotten the second one.
Solar sails. And
solar sails. So you're right. We haven't covered solar sails as much as the sort of rocket technology principles, but on the 4th day, under chipsats and other small concepts, we'll be discussing specifically solar and laser sail ideas. So that will come up on the 4th day.
Also, if I may add, I think that we are introducing solar sails in the introduction for propulsion on day 2.
Yes, so
if I remember correctly.
Some of that science will be mentioned earlier as well. So we've got a bit of science, but you're right, not as much as rocket technology. So that, shall we say, is the influence from LSI, but they are covered in concept-wise on day 4 as well. Comms fell out. Remember that long list of subjects that I suggested? The comms as a case study fell out of the list of what we would cover. So that I've got what I call a reserve lesson being written that covers specifically comms. And if I still feel it's something we can fit in, I might take some essential aspects of that and use it elsewhere. But you know, the case studies that you can see on day 3 really follow on from the propulsion and power issues. They're sort of a smooth follow on from that we look at the handling of the power, thermal control, look at radiation issues and stuff like that. So we picked, I think, 3 or 4 case studies that we'll talk about on day 3 to illustrate the systems. The challenge, I think, is probably just about every lesson that you can see on this the sheet. You could spend a whole term talking about in a school, at university or something, and we have to try and cover it in 90 minutes or less. So it is a challenge. I plan to do a full evaluation of the course after the course, So we will look at if the students attending say, well, we really did want more on solar sails, for example, or we could have done with a, a budget link equation. You could help us see that sort of thing, and we can tailor the course in the future, because this is something that LSI want to repeat in the future. We're doing it online this time because we have to deliver it online, but in future the plan is to do it in an in-person course in Houston, and repeat that, and maybe the course will evolve slightly over the years. So was there a fourth question, fourth point? Have I missed any?
I think it was power. That power is very important for every propulsion system. So for electric propulsion, we are talking about gigawatt systems or something like that.
Yeah. So that will be on the Wednesday under the power system case study. Effectively, that's looked at there, and a little bit comes up in the day before when the particular lessons are talking about those propulsion systems. They can't help but mention the power requirements of some of these things, so that does come up. So thank you for that, and that's all recorded, so I can double check we've covered everything. Any other questions while we're on that? I put the link because Sonny has put this on Eventbrite, so this is recorded for now, but it's under Eventbrite, under that summer course where tickets can be picked up, and I have to say it's a bargain price. I tried to get Sonny to push the price higher because they're effectively funding it. LSI, they're covering the extra cost of running it. And the price they've quoted is only a cost price. It's even less than cost price, but good on LSI. So hopefully that will encourage a few more people to attend. I mentioned that they're hoping it'll be more academic than we've done. I would say popular level mostly, although we have got into some depth with the ISU modules. So we have to do the academic side a bit more. So I was concerned about the fact that this was going to be all 4 sessions a day of 90 minutes for the students and the instructors, and I got in touch with some learning and development consultants who talked through some ideas of how we can break the sessions up a bit and the different activities we can undertake. So we've got plans to break out. We can still use breakout rooms, we can still do exercises, we won't have the workshops, we can do polling on. We're going to be using LSI's Zoom webinar / conference facility, so there's a lot more options there. With these learning and development guys, we realized we probably didn't want to go to the full virtual environment, which is what I've seen used for other courses, which I think long term it might develop into using a fully virtual environment, where you can go from, the lecture hall in virtual, you can go to the bar and talk to people in the bar, just like it was at a proper seminar or conference, that sort of thing. So that is possible for the future. So what have we done? So we created a lesson list. The first thing we did after this lesson this week, you can see the titles here, was create a synopsis for each one, which is still evolving, so I won't share it with you at the moment, but there's a synopsis, which is a paragraph of 2 describing what's in each of these lessons. And I've got as far now as we've got a set of learning outcomes for each lesson to go with the synopsis, to go with the title. So we're getting closer and closer. And I think, was it today, Patrick? I can't remember when the official deadline for people to provide me with their PowerPoint packs was today or yesterday, and I've been getting in the presentations from the guys, and I've got 2 or 3 weeks now to turn them around with a small team of reviewers to look at each individual presentation and then provide them to Sonny and LSI, and then we've got a few weeks before the course starts in the end of July. So any more questions about the course? Because the particular details on the course, I'm just going to move on from this slide, which is a key slide, I would say.
Rob, just one from me.
Yes.
What's our expectation of the students, both in terms of what kind of students we're expecting to attract and what we want them to go away from this having gained?
Well, okay, so that's the outcome for the course, really. You know, I think the biggest thing for me was to inspire people to, if they're in STEM, to stay into STEM, inspire them to go into space, stay into space, and get involved with some of these projects and think that there are real projects, and I'll come on to this in a moment, that they can get involved with, that they are going to work in their career, that are effectively on this roadmap that's going to take them to go interstellar. Give them, we can't give them everything, give them some knowledge, a grounding of all the topics they need to be thinking about before they down select into the area they're going to go to. And as I said, the main thing I think is to just inspire them, not to sell them a false bill of goods, as they say, but inspire them that there is potential for them to work in future.
Great, thanks.
Yeah, I've got a one-liner here, and it's basically that. So let's hope it works. I'm hopeful, because you know I'm very excited by this material, but it'll be the proof of the pudding will be in the eating with the students. That just led me on to, funny you should say that, because the next, can I select it from here? Now I've got the laser pointer on, it won't let me. So I'm learning how to use this. I have to turn the laser pointer off, and then I can go to this slide here. Get rid of that one. So I just put a bit of eye candy in, as I call it, just because if any of you are the Expanse TV show fans, this is some images from the TV show. And these guys are thinking just a couple of hundred, I don't know the exact time frame actually, is it 100 years or a couple of hundred years in the future? And they're talking about billions of people living in the solar system, and a solar system wide society made of people living on Mars, people living on the moon, in cities or in outposts. And in fact, I don't know if you can see the bottom right picture, there's even millions of people living out in the belt, either in habitats in space or even on some of the dwarf planet Ceres or the asteroids. And it's a fascinating, it's overly violent, the TV show. I don't know if the books are the same, but it's a fun and very graphically realistic future, which I don't think is hundreds of years in the future. You know, some of it may be, but I think in their lifetime, some of the students we're talking to now, there will be people on Mars, maybe not as many as predicted or hoped for. There will be ships, maybe not like the Rocinante here, which is a fusion-powered ship, a bit like there's a Daedalus nozzle on the end of it by the looks of things. No fuel, propellant, and no radiators, but there's that sort of thing. It may be just a advanced nuclear thermal electric hybrid that's getting us around the inner solar system. Who knows what exactly, but it's a great show for being making you think about what's possible in the future. And the reason we do that is even in the storyline, they talk about, this is Phoebe, which is a moon of Saturn, which in the story there's a research station there, and there's something they don't know what it is that's there. I don't want to spoil the show too much, but Phoebe is a moon of Saturn. It's way out more distance than most of the other moons, along with, is it Iapetus is the other moon that's out there, and it's a retrograde, so it goes the wrong way. It's highly inclined. It's obviously a captured object, probably captured from the Kuiper Belt or somewhere. But I was given a talk just the other week, which made me think this could be a captured centaur. And there's some people that are centaurs that are objects like asteroids, like comets, or cometary like asteroids that orbit around in the giant planet's orbits, which are obviously captured, probably disturbed from the Kuiper Belt. Possibly some of the very highly inclined, almost in polar orbit objects may not even be from the solar system. They may be captured interstellar objects. That's arguable. But in the storyline, there's something on here that they need to find out about. And there's something, a point in the chat. Let's see. So the Expanse, it says here, John, thank you very much, says kicks off in the year 2350, and the 6 series span 10 to 15 years. So we're up to series 5 at the moment. Yeah, good show for just inspiring you if you like great graphics of what it really could be like. But this could be a point. We want to encourage the students that might be on the course to think we could investigate this object, presumably with robotic probes to start off, but how long down the line before we might have humans out in the orbit of Saturn, that sort of area, you know? And I talk about Triton elsewhere, of course, because Triton and some of these other bodies have actually have subsurface oceans of salty water. There's you know, the astrobiologists are just dying to find out what are there. We need to go out there and investigate these things, and the value to science will be absolutely ginormous, just amazing. And that's the one thing I think, I talk about this stuff sometimes, there's one thing that's going to pay for some of these things. If crazy entrepreneurs don't get round to it, then science agencies will be pushing to find out sort of things. Again, Triton is just a huge moon. It's retrograde, goes the wrong way around in orbit in Neptune, very likely captured Kuiper Belt object, very likely similar in makeup to Pluto and those other things. So if we want to find out about Kuiper Belt objects, maybe we go to Triton, and that's possible. I don't know whether I'm going to see that sort of thing, but I think in the careers of the students that will be possible. And just to finish off, then there is a flyer which I'll send out to everyone. I'll just send out a flyer. So that's the date of the first course, July 26th to 30th. There's a bit of blurb that you'll have heard me talk about on the this evening about the course. It'd be great if you could take this flyer and feel free to promote it to people you know, or your contact lists, or students, or whatever you're involved with. Please feel free to help us out and publicize this course. I mean, we're all engineers and scientists really, so marketing might not be our forte. So any help we can get. Thanks, Patrick. I saw you laughing your head off there. We're not necessarily experts in that field, so if you have a chance to help us out, please do. And I'll just finish off a couple of things. Is we have to be ambitious. We have to change from being short-term thinking to a long-term thinking civilization, and we can go from in a few hundred years to the Kon-Tiki sailing the Pacific to huge ships, and in space size is no object. So we'll be building giant ships in the future in space. And you know, it takes me back to that quote. Is it an Arthur C. Clarke quote? Whatever's possible will be achieved. And I can't remember the exact quote. Some of you probably know it. But you know, whatever's possible, physically, scientifically possible, we will achieve. So that's a bit about what I4S tried to promote, and of course LSI. One I always show is try to think of people like Alan Bond, who's one of the key people from the 70s, still around now, encouraged me to go down this route. He's been designing the single-stage orbit space plane for years, or the power propulsion system for it. So we're just chipping away from the problem. Part of the educational side of thing will be to do this. And okay, there's there's that John again, says not keen on leaving the solar system to crazy entrepreneurs unchecked. That may be a good point. The Expanse is an object lesson as to why that might not always be a good idea. I would disagree with you on that, John, and I'd say too many of the individuals on that have proved the opposite of unchecked crazy entrepreneurs, because there's one very crazy entrepreneur, I would say that, but there are thousands of crazy ordinary people who would behave unlike ordinary people I ever know. So I don't know where we sit on that one, but yeah, it'll be interesting to see how that pans out. I'll leave the advert for Principium on there. You know, it's our quarterly magazine, it's free. You'll see information about the course and other stuff that we do on there. And I think that was the end of my slides.